So this section 2.5a will be about solving polynomial equations and other type of equations that I sometimes call weird equations. So let's start with the polynomial equations. Clearly you can say that you can tell that these equations are not quadratic because the highest power is not 2, the highest power is 3. So the advantage of these equations in the approach that we're going to use is the fact that we have 4-term expression for these equations. We can attempt to use solving by factoring, which starts by moving all the terms on one side of the equality sign. So let's move, let's add 6 on both sides. So the equation becomes x to the third minus 2x squared minus 3x plus 6 equals 0. So we can make two groups. That's the first group, and that can be the second group. The greatest common factor of the first group, GCF, is x squared. We factor it out, divide each term by x squared. The first term divided by x squared is x. Divide this one by x squared is going to be just -2. The GCF of the second group, I'm always going to bring the negative sign with the GCF. So that's going to be negative 3. So divide by -3 the first term, that's just x. Divide by -3, that's going to be -2 equals 0. So that's x minus 2 times x squared minus 3 equals 0. Now we can use the zero product principle. That will be x minus 2 equals 0, or x squared minus 3 equals 0. And we can solve each equation separately. But the first one, add 2 on both sides. X equals 2. The second one, I'm going to isolate x squared and use the square root property. So I add 3 on both sides. So that's x squared equals 3. The square root property, x will be, if x squared equals 3, then x will be square root of 3, or x can also be negative square root of 3. We have 3 values possible for x, so the solution set will be 2 square root of 3 negative square root of 3. If you want to simplify your answer, the writing of the solution set, you can say that your solution, you can also write it as 2 plus minus square root of 3. So that also can be considered as your solution set. Okay, so next problem. Solve the equation, and you can give your solutions in complex form too, by the way. Here we have all the equation on one side, so we can just group by 2 terms and then try to factor by grouping. That's my first group and the second group. And now let's try to factor the GCF from the first group. That's x squared. When we factor it out, that's going to be 2x minus 7. And the second group, the GCF will be 9 plus 9 2x minus 7 equals 0. Then when we factor the 2x minus 7 out, it will be 2x minus 7 times x squared plus 9 equals 0. Then now we are at this point where you can use the zero product principle. 2x minus 7 equals 0, or x squared plus 9 equals 0. Let's add 7 on both sides. 2x equals 7. We can divide by 2 to isolate x. Get x equals 7 over 2. Subtract 9 on both sides. X squared is negative 9. Use the square root principle. X equals square root of negative 9. X equals negative square root of negative 9. But when you have the square root, the negative sign inside of square root, it will require that you introduce the imaginary number I, which is square root of negative 1. So that would get you to x equals 3i, or x equals negative 3i. Three solutions, two of them are complex, and one is real solution. So the solution set is 7 over 2, 3i, or negative 3i. So this is the solution set for this equation. Next equation here, we have both sides with the expressions, but since when you're solving these equations with the power of the variable different from term to term, you have to move all the terms on one side. Now to move the terms on one side, I'm gonna subtract 54x and add 45 on this side. On the other side, I'm gonna do the same thing, minus 54x and then plus 45. So these cancel on this side. On the left side, we're gonna have 6x to the third minus 5x squared minus 54x plus 45 equals 0. Now with that, we can group the first two and then the last two, and then the last two, and then we will factor the GCF of each group separately. The first group GCF is x squared as well, so that's 6x minus 5. The second group GCF will be negative 9, and that's 6x minus 5 equals 0. Then 6x minus 5 repeats for each group. We can factor it out. 6x minus 5 factor x squared minus 9 equals 0. Now, zero product principle, that's 6x minus 5 equals 0, or 6x minus 9 equals 0. We can add 5 on both sides for the first part of the equation. 6x equals 5, then divide by 5. X equals, divide by, not 5, divide by 6 to isolate x. Divide by 6. And then 5, 6 is the first solution. The second one, we can add 9 on both sides and then use the square root principle, which will give you x equals square root of 9, or x equals negative square root of 9, x equals 3, or x equals negative 3. So we have two more solutions, and the solution set will be 5 over 6, 3, and or negative 3. That is your solution set for this equation. Um, the next equation here, it's different, and I want you to point out the fact that this equation has a radical, but we've never solved any equation with radical. So it's weird, this equation. We can bring it back to something that is more solvable, or that is closer to what we've done so far. So to do so, I'm going to call another variable square root of x. However, whenever you finish solving the equation, the new equation that you're going to create with naming square root of x something else, you need to go back to this variable so you can find the solution of the given equation. So that said, let square root of x equals, I'm going to call it t, for example. Now, if square root of x equals t, if we square both sides of the equation, we would have square root of x squared equals t squared, which is x equals t squared. Now that we have this, we have x in terms of t, and we have square root of x in terms of t. We can replace them back in the equation so we can have a better look of our equation that we can solve with by quadratic. So x is t squared. So that's t squared, and square root of x is t. So that's negative 5t minus 24 equals 0. So now this new look of the equation looks a better situation for me to solve, because I know how to solve quadratic equations. Now, by factoring, if I break this into two factors, since the coefficient of x is 1, I'm going to break the constant c into two factors that the sum is negative 5. These two factors are negative 8 and 3. So with that, I'm going to have t minus 8 times t plus 3 equals 0. So I'm going to solve this easily by solving t minus 8 equals 0, or t plus 3 equals 0. So if we add 8 on both sides, t equals 8. On the other side, if we subtract 3 on both sides, t will be negative 3. But we need to remember here, t was not our solution, our variable. So we need to go back to the initial original variable so we can find the solution of the original equation, because we had this equation as a kind of a bridge for us to go from the weirdness of the problem to solving an equation, but we never want to forget to go back to the previous equation that we were solving. So with the previous variable, t was square root of x. So square root of x equals 8. And then we're going to have, if we square both sides, square root of x squared equals 8 squared. We will have x equals 64. So we have one value for x. Let's see the second option. The second option will mean that we have square root of x equals negative 3, which is not true. It's impossible to have the square root of a number negative. It's impossible. So this one will not end up giving me no solution. So because this is impossible, we reject this option. Reject it. So we would end up getting one solution for this equation, that is 64. So the solution of the equation is 64. Okay, next. This one also is weird, but one thing we know is that we know if we have x to the 2/3 power, it equals to x to the 1/3 power raised to the second, because when we have a to the power n p, it's a to the power np, right? If we have a to the power n raised to the power p, then it equals to a to the power n times p. So these two are the same, and we can rewrite it as the equation as x to the power 1/3 squared minus 4x to the power 1/3. And then we would subtract 21 on both sides. Minus 21 equals 0. And we're going to have, let's say, x to the power 1/3, which is the part that is the most weird in the equation. So we're going to change it, equals, let me call it y, for example. So in my equation, I'm going to create a new variable, a new equation in variable y, that's going to be y to the one to the second, because this is y. So y squared minus 4y minus 21 equals 0. So with that, I can factor negative 21 in two factors that the sum is -4, that's -7 and 3. And then because the coefficient of y is 1, we need to remember that if it wasn't 1, we would multiply coefficient of y squared and constant. But now we can just draw the answer as y minus 7 times y plus 3 equals 0, and then solve y minus 7 equals 0, or y plus 3 equals 0. So add 7, y equals 0, 1, 7, sorry, and subtract 3, y equals -3. So this is only the solution for the bridge variable that we called earlier. Now we can change it to, since y was x to the 1/3 power, so that's x to the 1/3 power equals 7, or x to the 1/3 power equals -3. Now, if we raise both sides of each equation to the power 3, that would cancel the 1/3. It will be x to the power 1. So x 1/3 raised to the third equals 7 raised to the third, or x over 1/3 to the third equals -3 to the third. So this would be x power 1, because 1/3 times 1 is 1, equals 7 is 343. 7 to the third is 343, or x equals -3 to the third. -3 times -3 times -3 is -27, which gives you the solution set 343, -27. So that's the solution for this equation here. Now let's see the next example. Same thing, we will call y equals, let me call u instead. U equals x to the 1/3. So that is going to be, the equation will become 5u squared minus 3u minus 2 equals 0. So for this equation, a is not 1, a is 5. We would multiply a and c to get -10. A times c is -10. Two factors of -10, that the sum is Negative 3 would be negative 5 times 2. And then bring it here as negative 5x plus 2. And then that is 5u squared minus 2 on this side equals 0. Then factor by grouping, right? That's my second group here. So GCF of the first group would be 5u. Well, actually, that's u here. And then u over here as well. So that's 5u factor u minus 1, and then plus 2 u minus 1 equals 0. Then we factor the u minus 1 again, times 5u plus 2 equals 0. Then with that, we can solve by using the zero product principle. U minus 1 equals 0, or 5u plus 2 equals 0. So we add 1, u equals 1, or 5u equals negative 2. If we subtract 2 on both sides and divide by 5, we get u equals negative 2 over 5. Now go back to your previous variable. U was x to the power 1/3. So that's x to the power 1/3 equals 1. If you raise both sides to the power 3, x will be 1 for the first one. And the second one, if we raise, we would have x to the power 1/3 equals negative 2 to the 5th, raising both sides to the power 1/3. That will be negative 2 over 5 raised to the power 1/3, to the third power. X equals negative 8 over 125. So your solution set here is 1 and negative 8 over 125.